Let these 36 cells out of the 48 volt 50 amp hour Chevy Volt lithium module sit overnight, and this morning they're still showing the same 3.2 volts per cell. And now I'm gonna try to clean up our tabs a little bit where they're kind of jagged, and then also see if maybe we can punch some holes in them for connecting purposes, like terminals. I'm using these flat press tool to flatten out our terminals first of all. They got kind of bent up from the puffing or removing. Just because it's metal, you got to make sure you don't hit both terminals at once. Just same thing, scissors, you kind of trim off where we're on a bit of an angle and maybe knock off these corners. What I have noticed so far is the negative terminals seem to have like a copperness in the middle, and they're thicker and they're harder to cut, where the positive terminals is just the aluminum tab. It's not as thick or beefy as the negative terminals. Yeah, that looks a little bit better. Not so jagged or dangerous. Alrighty. And as far as being able to maybe ever connect these back together using our terminals here, I doubt very highly solder is going to stick to any aluminum. So we're going to have to do more of a mechanical bond. So maybe some just simple 1/4 inch nuts and bolts. And since it's just like a heavy duty foil, maybe a hole punch, give us a 1/4 inch hole right in the middle of each terminal. And for alignment purposes, we want to make sure all the holes are in the middle. So we'll mark them all in the middle. And then there's a lamination line right about here, so I would say we'll just try to stay above that and give us as much bite right there. That was the positive one. That one's easy. The negative one here is quite tougher. Line up on our mark. It takes a bit more effort. After punching your holes in them, just line them up and put your bolts through them. So now this cell group is reconnected electrically and mechanically. Or if you was to take these three and flip them back and forth, you would put them in series. Right now they're in parallel. Picked up some brass bolts, 1/4" nuts and bolts, and the head's about a 1/2 inch, and so is the nut. And another option is we could just simply bolt the modules together through the punched out hole. So this would be like our positive terminal. They're connected in series here, negative to positive, and this would be the negative terminal if it was just a 2-cell battery pack, or this connects to the positive of the next, and we'll keep on going. So with the meter just connected to 1 cell, I've also got it set down to a finer setting, so we're at 3.19 volts. And then we move our positive up to, well, not our positive, our negative. Push that tape back a little bit. Get a connection here. And then when we have them connected in series, our meter's showing 6.38. And then when you stand them up, that's just separated a bit, but kind of bringing them together, probably with one of these pads in between, and then connect this next set of cells, or the next cell, just like this. Another pad and another cell. And then we'll put some kind of a plate on each end and a clamping device of some kind to secure it and add a little bit of pressure. So I've got 7 of our cells connected so far. 1, 2, 3, 4, 5, 6, and 7. Got my pointer Floyd. And so our first cell group comes in at 3.2. Jump up to the next one. We're at 6.3. Next one's 9.5. Next one's 12.7. 15.8. 19.0. And then we tuck in our protective cover here. And up to our 7th, we're at 22.2 volts. And then I've got our insulator in between each of the adjoining terminals. So I'll keep doing that with, this is cell 1 through 7. I've been keeping them in order, so we'll use 8, 9, and then all the way up through 14. Now we'll insert another one of our insulators. Square it off. Our next cell. Nut in the bolt. On and on and on. And as you can see, our next terminal is our negative terminal. So that goes to the positive of this cell. And then on and on. Just to be clear. Before I do anything, I tape off the terminal that I won't be using, and then I untape the previous terminal that I wasn't using to expose just one at a time and try to do it methodically and safely. Remove the tape off the cell we're not using any, or the cell we need to connect. There we go. Alrighty, that's our 14th cell connected in series. Now we'll put a piece of insulator tape over top of it. Fold it down. There we go. Alrighty, I've got our 14S lithium battery pack assembled. Now we're going to double check the polarity, that they're all connected in series, and record the voltages as we go up. So our first cell comes in at 3.2, and I've got the positive hooked to the positive here. Second comes in at 6.3. Third, 9.5. Fourth at 12.7. Fifth at 15.8. The sixth at 19 volts. Seventh at 22.2 volts. Eighth at 31.7 volts. The ninth at 34.9 volts. And we're at 38.1. Oops, the next one. 40.12. And then we get to the 14th cell. We are at 44.4 volts. So our polarity seems to check out okay. And we've got more data. 44.4 volts. Alrighty, and I noticed at the 12S mark we was at showing 38 volts, and when it was a whole volt pack 12S it was showing 38.4 volts. Just to note that little bit of a difference. And for the record, our first slightly puffed module that we reclamped together about 5 days ago is still holding pretty steady at around 46.5 volts. Here's our 14S battery pack laying sideways, and it's coming in at about 4 inches uncompressed. I'd say this one. push down a bit more. So, and I'm working on a battery box cover side. I'm gonna try to have a voltage meter in it so we can keep an eye on the voltage. I'm working on cutting it out, and also a 48 volt 50 amp circuit breaker. That way we got a fuse or circuit breaker protection, but also a master on-off switch. Alrighty, I got the cutout for our circuit breaker. Our circuit breaker pretty much installed, and also the cutout for our voltage meter. You just pop in like that. Well, our circuit breaker has a battery line side to the left, and then the auxiliary or load is on the right. Got our piece in the bender. I've bent up the first side. Now I've got a 6.5 inch gap here. And I'll bend up this side. Well, here's our two-piece battery cover so far. Got the bottom side on, and that could be the top side. I made them to overlap a bit for compressibility. And that should protect ourselves on all sides. Leave our terminals at least a 1/2 inch, and should be nice and even on the bottom. I got our cells all connected together into a 14S configuration. I've added our spacers, insulators in between each. I've also went ahead and double insulated so we have no open terminals anywhere. Now we've got a box to put around it. I've also insulated the top edge just to be sure. It shouldn't be nowhere near the terminals. And we'll have a top on our box. It will have a circuit breaker for circuit breaker protection, and also we can use it as a master on and off switch for the battery pack. And I also installed a voltage meter so we can keep track of what's going on with the battery pack. And our clamping brackets. So time to get her all put together. So the first half of our battery box, then we'll put one of these pads in there that come with the cells. And I figure we'll put the shiny side against there, and then the soft, more foam rubber side against the cells. Well, there's our 14 cells installed in the bottom half of the pack with our pad underneath. And our top should just slide right on. Alright, there's both sides of our battery box. Just make sure all our cells are nice and even. And then it'll squeeze together decent to be able to pressurize things. Well, I've got our 14S battery pack assembled and in the case, in the mounting brackets, and it's showing 44.5 volts at the moment. All of our terminals don't seem too awful constrained or anything, although I'm not sure with our bolt heads sticking off each end if it's going to give us an issue with mounting our lid on. Looking over our battery pack, like I said, I think these nuts and bolts for our positive and minus terminals are going to affect our lid, because our lid's supposed to bolt right on these bolts here. I'm thinking maybe if I move it over to here, there's a bit of a space behind it. I'll turn the nut around and it can hang out in that area. Same with here. That's still pretty bulky for what we want to do. Maybe try a little bit smaller screw. The washer, we still got about the same head. Less bulk. I think that might work. Getting our battery top wired up here. So our positive terminal right here will connect to the red wire. Goes to the battery line side of our circuit breaker, and then the auxiliary or load side will exit. And also our meter, I've got the power or the positive hooked up to the auxiliary load side, so the meter will only come on when the circuit breaker is on, so it won't be a constant draw. And then our negative will hook to our negative terminal here. And then I've got our negative wire that will exit. Also, I wanted to note our negative terminals are all like a copper with just like a aluminum coating on them, so they're a bit thicker. The positive terminals is just the aluminum, so they're not as beefy. So I was worried about our aluminum terminal. So I harvested one of these copper brackets out of our top here. I folded it over and drilled out the same size hole that we'll be using. I'm going to slide it over our positive terminal to beef it up, and then I'll connect our positive wire. And we have our positive terminal beefed up and connected. Like I said, this will be our exit wire for the power and charging. Now here's our pretty much done battery pack. These can be used for mounting. they also compress it back together. And then right now it's at 44.4 volts. And then we'll use the same line for charging and discharging. Keep it simple. So now we'll just have to connect the 14S charger and get her charged up. I'll monitor it and let it sit for a few days and settle, and then we'll do some discharge tests. More to come.